Can you hear me, guys? Yes? It was exciting, wasn't it? Congratulations to the winner of the Serverless laptop. I wish I would get one, but I didn't. But I'm going to talk about something also very interesting, which is Azure Serverless. My name is Tomasz Wiśniewski. I'm a technical evangelist here in Microsoft Poland, and I was designated to talk to you about this subject. It was talked in the keynote from Larry. And now we will go a little bit deeper on that subject. We'll do a couple of slides, and then we'll do a demo so you can see how to create an Azure serverless application and how to use it in your existing application, because you can do it both ways. First of all, I want to just emphasize what serverless is. First of all, serverless is a part of our platform as a service offering. Platform as a service, or PaaS, in short, means that we want you to focus on your business logic. We don't want you to focus on the infrastructure, on the machines that you have. We want you to focus on your application. And that's the 3 points that we have here on the slides. First of all, it's abstraction of servers. Both the operating system and the framework is managed by us. You don't have to do anything. All the updates, all the infrastructure, things that you normally have to do with virtual machines are taken away from you. You just give us your code, a function, and you just put it into our servers, and it runs. That's it. Second of all, serverless computing is one of the most important things of serverless computing is scale. Serverless computing scales very rapidly and very fast based on the demand you have. You do not set any scale settings. By the way, in Azure Functions, you cannot even set scale settings. If more load comes to your application, your server, it just scales, and it can manage many thousands of concurrent connections. And what's also important, it's event-driven. As Larry said previously, we have a lot of connectors, a lot of events that you can subscribe to or be based on that will launch your solution, your application. And the third and very also important thing in that is that your functions can run for a very short time. That's why we have introduced something what is called micro-billing, that you will get literally billed for seconds of execution of your application. So, let's now look at our Microsoft stack for serverless computing. In the middle, we have our two compute platforms that you can use to run and create your serverless applications. First of all, you have Azure Functions. Azure Functions is an event-based computing mechanism when you put your code, your function, and there's event which you subscribe to. It's also open source, like many things in Microsoft nowadays. And what's even more interesting, I know you all love Azure, but if you cannot run it on Azure, you can also run it on premises on your own servers, because recently we have launched Azure Functions Runtime, which can be run literally anywhere. On the other side, we have Logic Apps. Logic App is an orchestration engine which allows you to orchestrate a lot of applications, a lot of functions in a visual designer way. It has a lot of connectors. I will talk about those connectors later to show you how it's done. And when you have your functions and your logic apps, it's all great, but the functions and logic apps by themselves wouldn't do much. The thing that is very important is also the elements that you can see on the bottom. First of all, with Azure Functions, you can connect to a lot of storage mechanisms, like Azure Storage or Cosmos DBs, based on triggers and bindings. And using that, you can, for example, subscribe to a new file, upring in the Azure storage, and then something happens. Second of all, you have messaging. You can use something like Azure Service Bus and topics to use your messaging in your application. Then you can connect to a lot of things with the gateway connectors, and in here I'm talking specifically about logic apps. Of course, you can use a lot of intelligence in your applications. You can connect to Azure Machine Learning, to cognitive services, and stuff like that to enhance your applications with artificial intelligence. And the last thing are bots. Andy talked about bots in his session. We also have something in Azure which is called Azure Bot Service, where you do not have to create your own server and host your API REST endpoint that Andy was describing. It's all serverless. You just create your bot. It's run for you by us. You don't have to administer any servers. And as Microsoft is well known for building developer tools, developer ecosystems, of course, serverless is very well put it here, because we have a local development environment. You can use local debugging. You can use a lot of tools to debug this. So it's not something new that you have to get accustomed to and learn a lot of new things to use in your day-to-day solutions. So Azure Functions. Now it will be a great animation. Just be prepared for it. As I said, we have code, which can be C# or Node.js, which we'll see in a moment. And you have events. And that's how the Azure Functions logo was born. So this is Azure Function, code and events that creates the function. And here is a simple sample code from Node.js, where you can see that we have bindings, which I was talking about earlier, where we define our connection to different endpoints, to different systems, to different sources we want to use in our application. And these objects can then be used around the code to have them just in hand anytime you need. That was Node.js, and here is C#. By the way, maybe I won't ask this question, maybe later. What we are seeing here is a sample of a function written in C#. It's the same function that was earlier. First of all, you have a class. You define in a compiled class library your functions. Then you specify a function name. Here it is review image and text, which you give an attribute. And what's very important, in one of your class, you can have many functions. So you can put them in one class. Then you specify a trigger. Here you can see a queue trigger, and you specify a queue name. This is an Azure queue. And then you put some bindings to different elements. Here you can see a Azure blob storage and also a document DB to use in the code, which is below. So we're going to do a demo. And this demo is going to consist of a couple of things. First of all, we are going to do some local debugging. We'll run the Azure function locally. Then I will show you how you can publish the Azure function into Azure. We'll also see a part of continuous integration and also application insights, which was already mentioned, which can emit telemetry into your monitoring system. Just to let me take a sip of water. Just to let you know how the demo is going to look. We are going to have a user who is going to upload pictures of cats, because internet is about cats, isn't it, into a website. This website is going to store the image in blob storage. It's also going to put a new message in the queue. And it's also going to create a new document in our DocumentDB service for other components to use. Then this queue is going to be picked up by the Azure function that we are going to write. And the Azure function will reach out to DocumentDB to see the link for the Azure blob storage. And then the Azure function is going to use two of our cognitive services. First of all, it will be content moderator to see if the text which has been written by the user is correct, not violating any issues. And also computer vision to see if that is the image that we want. So this is the demo that we are going to walk through. So now let's hope, as we got 1 minute to do it. I will just try to make it as fast as possible. OK. So Visual Studio. You write your Azure functions in Visual Studio. You can use other tools, but of course, Visual Studio is great. When you install the tools, first of all, in File, New Project, in the Cloud section, you will find an Azure function template which you can easily use. If you have a project already in your application, you can right-click on it, click Add, and choose Class. Here, you will also find Azure functions, which when you try to add, it gives you all the templates that you can also find in the Azure portal, because it's also very important that you can write your Azure functions directly in the portal. So what do we have here? Here we have the same code that you basically saw on the slide. We have a class, we have a function name, which defines our function, our queue trigger, and our bindings to our blob storage, and DocumentDB to reach to our documents. Here I have the great website. And first of all, what the code does, it doesn't do any image validation. All it does is runs this method, which is called passes text moderation, and it just calls our API with a basic HTTP request to see if the text is correct. So this is the first version of the app. I can show you how to run it. You just click it, F5, and our local function runtime is getting invoked, and it's ready for action. Maybe I will put it somewhere here, and I will launch our website, add a picture, and let's find an image. This is a beautiful cat, isn't it? Yes. Let's try typing cat. Click Create. And if the internet is working, or maybe not. Oh, as you can see, in the meantime, the page has not refreshed, but you can see that the function has been executed already, as it's almost near real-time execution. So it's faster, even the website is refreshing. You can see the status is pending, but when I refresh it, it's got approved. But as we know, this is not a cat, yes? Or maybe you want to play the game again and tell me if that's a cat. But I don't have any prizes, so sorry for that. So let's stop it. And now we will modify it. I will do the best developer experience stuff, which is comment uncomment. And here I have modified the code that besides the text moderation that we are doing, we are also using an image check. We are using our Vision Service client, and we are providing it the image that we want to upload to see if it is the image that we are looking for. And now when we run the code, okay, the function is running locally. I will return to reviews. And add a picture again of the same dog. It doesn't really matter. Let's see, great cat. I click Create. And now in a moment, you will see that the function will get executed. Okay, the page has refreshed. Now the website was faster. The function gets executed. The queue from the message from the queue is getting picked up. And now when we refresh, you see that this is a brown dog carrying a frisbee in its mouth. Maybe it's not a frisbee, but it's good enough for our description to see that it's not a cat. Just to prove you that everything is fine, now we'll upload a true cat, a cute little one, cute cat, create. Again, in a moment, the function will get executed. Anticipation, excitement. Someone clicked right on the spot. Excellent. F5. And you can see that it is approved, a cat sitting on a counter, which is quite nice. And just to prove you that everything is working fine, if someone is going to be offended now, sorry, we'll put the cat and we'll write something like shit happens. Because that's true. That's just how it is. And now, despite this being a cat, it's completed. But it will also get rejected from our system. So as you can see, in a simple way, we have wrote a simple little piece of code, business logic, that we can put in our website to enhance it and work it based on our load. And now going back to the publishing side of the story. Of course, you can right-click on a project and click Publish. And when you have Azure SDK and Azure Function tools installed, you will get an option to deploy an Azure function to your Azure subscription. But professional developers, as we all are, don't do that this way. We usually use some kind of continuous integration, continuous deployment system. One of the systems can be, sorry, this is not the thing I wanted, could be Visual Studio Team Services. If you haven't seen Visual Studio Team Services, I highly recommend you to go to visualstudio.com and create an account, which is free. And here we have defined a build process, which will build our Azure function and then later deploy it to Azure. So now, when I made some changes to my code, I can right-click on it, or maybe let's do it from Team Explorer, select Changes, and edit image validation, and I will commit it to our local repository and immediately push to our remote repository in Visual Studio Team Services, which is also Git-based. And as soon as that happens, it got pushed. When I come back to my Team Explorer, I can see builds. Immediately, a new build has been kicked off and will just continue with the continuous integration and continuous deployment element. Because we are running short of time due to the long contest, which was great, by the way, I will go back to the application insights element and putting telemetry. This is a dashboard, a custom dashboard created based on application insights, which are embedded in the Azure function and the website. Here you can see the analytics of our images that have been added. Like you can see that there are 5 images passed, 3 failed, text failed with text, some text failed, and stuff like that. You can also refresh it. I don't know if it was, yeah, it updated for the recent ones. You also get an application map, which is very useful. You can see how your requests are flowing through your system, and you can see the low points of your application. And if you want to go really deep on that, we also have something which is called Application Insight Analytics, where you have a full query language, where you can run queries and see different results. You see, this is the result that we had on our dashboard. I can change the type of the chart and pin it to my Azure dashboard, so you can basically do anything with the telemetry that you are taking out from your application. So that was Application Insights. And this I didn't want. And now Logic Apps, the second part of our serverless computing offer. Logic App is a very powerful and really cloud-born, because it was created for Azure, orchestrating mechanism for many different things. First of all, of course, you can orchestrate Azure functions, but you can also create flows from many different systems. As you can see, you can pass different parameters from one system to another system. You can take file names, you can take variables and stuff like that. And what's also very important, it's not just a visual designer, because that is very nice and pretty for a demo, but in your real life, you usually need code, which defines your workflow. And also, Azure Logic Apps is basically a JSON document that you can put into your source control and deploy together with your application to have it up and running. And as it was mentioned also before, and I want to emphasize it really strongly, Logic App is here for you to orchestrate basically everything on the planet. From bunch of Azure services, which you can see on your left side, to third-party services like Office 365, DocuSign. Also very popular SaaS applications from Facebook, Twitter, Box, many different connectors. But what's also very interesting and important, we also have an on-premises gateway. If you want to connect it to your local environment, your SQL database, to your SharePoint intranet site, you can do that with Logic App and orchestrate that flow through Logic Apps. And to summarize, guys, Azure has a very comprehensive serverless platform for you to use today. Azure Functions and Azure Logic Apps are the way to go. You have a lot of bindings, you have local development, which is great, and Logic Apps has a lot of connectors, which you can also write yourself if you want to have them being used in Logic Apps. You will find the links in the decks later, and also you can find the whole demo on our GitHub repository for you to use and play around and deploy it in your local environment to play around with Azure functions. And with that, guys, I would like to thank you for this short session and have a great rest of the day. Thank you.